Hello, everyone. This is a video that has a couple of my latest interests coming off. A couple of years ago, Christmas before last, I believe, I asked for and received the Parallax Board of Education or BOBOT robot kit for Arduino, and I didn't do anything with it. And I felt like I should do something with it, so I got um, put it together and had some fun. What I'm leading up to is a summer project with my 7-year-old granddaughter, but I wanted to put it together myself first so that I'd look smart, or conversely, not look stupid when we're putting it together. So the last uh, version of the robot, it went through several different iterations. The last one used IR, and since I had some IR stuff lying around, I got interested in that. So I'm going to show you is the robot using IR for proximity sensing. And it's interesting that for you Adafruit fans, of which I am a big Adafruit fan, um, so I am one. Um, the recent Desk of Lady Ada, this is April 2017, there were 4 episodes on IR, just coincidentally, so I was able to use those. And I made heavy use of the Adafruit learning system. Um, So what we're going to see is first the demonstration of the robot, then 2 different versions of how to decode IR. Uh, the initial tutorial off the Adafruit Learning Center, and then a very recent one that was done by Chris Young, Cyborg 5. And I think a lot of Chris. I'm also a fan of the Adafruit Show and Tell. I've been on it a few times. And Chris has been on it regularly and always has something very interesting to show. So he wrote another IR library. So I'll show you the first way, and then show you Chris's way of doing it, which is much easier, much more user friendly, I would say, programmer friendly. Um, and in the process, I play with an Adafruit 8x8 bicolor LED matrix, which I also had lying around, so I decided to play with that. Just incidentally, I have a larger 32 by 32 matrix that I plan to use as a parking sensor. And this, I've had this for a while, a parking assistant. So I'll put up this big matrix in my garage, and as I get closer, to have the matrix draw different faces. Well, I decided to use the little matrix to demonstrate the concept. I've done this with a ultrasonic sensor and a tricolor LED, and it works. I just haven't gotten around to doing the big project yet. So that's why I use the LED matrix. And thanks to Phil B and the library that he put together for the 8x8 bicolor matrix. And so I used some of his code and modified some of that stuff. So all that's coming. And then I'm using some continuous rotation servers, showing how I can control those also from an IR remote, which is kind of fun. I have it set. I have it on a Adafruit Bluefruit Feather, and I've used the Bluetooth to control the servos. Wanted to see if I could also do it with IR, and I can. So demonstrate that, and then finally just one more little something that's interesting, at least to me, on the IR and the robot. So that's what we're going to do. First up, the robot. Okay, this is the Parallax Board of Education shield, or BOBOT. See it there from the top. The infrared stuff is over here, These are two infrared senders, and the infrared receivers there and there take the infrared that is sent out that way and bounces off an object and comes back. So that's doing proximity sensing. Let's take a look and see how this works. We'll take them, plug them in, and flip the switch on and turn them on. He heads over that obstacle there, and now he turns around, turns away from it, moves slowly up in this way. I'll try to stay out of the light. And so he just was able to turn around, avoiding the bookcase there. You can't avoid the cane. Keeps on moving around, and avoid some more objects. So that's the idea, IR sensing for proximity sensing. Pretty cool. Okay, everybody, what we're going to show next is how the first way we decoded IR. This is a Arduino Uno with some stuff set up on a breadboard, a matrix that we're going to see work later. But first, we're just going to decode IR. This little black thing right there, that's an IR receiver, just like we had on the robot. This is a remote from a TV. So what we're going to do is see on the we have code running in the Arduino, and on the serial monitor we should see results when we press the button. So we'll press the up arrow button right here, and it's restarted. So we'll do it again. That's one thing about this code that I didn't like, was sometimes it takes several hits to get you to decode something. It says it's ready, but it's not decoding. This is, and by the way, what that means is that there it goes. So what it just gave you all those numbers. And that's one, as I say, that's one drawback of this code, is that it gives you, first of all, it gives you this big dump of stuff. And what you have to do is take from there, and where it says IR signal, change that to a name, drop it down here, and take all the rest, and do that for every button that you want to decode. As I say, this code is not is suboptimal, let's say. So, but I'll show you how that works. All right, so here we are. This code is called IR Commander VM Matrix, as in virtual machine using a matrix. The thing that I wanted to show you was up here, this library, IR codes VM, as in virtual machine, because I took the code that was provided in the tutorial on the Adafruit Learning System and modified it for the codes that I decoded. So all that stuff that we saw earlier that came in on the serial monitor, each one that said IR something in it, we changed that to a name that we can use in our code, and we do that for every button that we wanted to decode. So we have write, and I couldn't, as I could say, I couldn't do all of them. So I have 5, and I have to channel down, and I have A down, A and D, whatever buttons. So those are the buttons that I was able to decode. And then in the code itself over here, in the sketch itself, we're able to check for IR forward, IR right, IR5, etc. And take actions based on them. Okay, and then what they're going to do is draw a matrix. These were provided by in Phil B's tutorial. So the smile, neutral, and frown there, those were created, and I just used the code that was given. So code's uploaded. So let's see what happens. It defaults to neutral. You see the neutral there. That's in the setup. It draws the neutral face. So if I press the up arrow, it gives you a nice smiley face. If I press the right arrow, it gives you a frowning face. If I press A, it gives you a blinking neutral face. If I press D, it gives you a slowly blinking frowning face. If I give you a the other one was 5, gives you a red neutral face. And if I press anything else, gives you a slowly blinking red frowning face. So a little bit of the capabilities of the matrix, but mostly that's the IR buttons will be decoded. So in the next video, next segment, I will show you a much easier way to do all this. Okay, so thank you very much. All right, this is code from Chris Young on the Adafruit learning system. As you can see, it's a lot shorter and a lot simpler. His library IR Lib 2 simplifies the process and also has additional capabilities. So what you see is this is the decoding, and the only thing I want to mention is that over here there's a line that says true where Chris had it. That gives you a bunch of detail. I changed it to false as his suggestion. His comment says use false for less detail. I wanted less detail. Over here in the serial monitor, it says ready to receive IR. So let's do it. That was the up arrow I pressed. Right arrow. So, and it if you leave it pressed down, it's going to give you multiple things, but that's okay. Multiple occurrences. What you're looking for is this value, and that's the value that we need. You notice that it has it gives you what the protocol is. It has multiple protocols, and that's what we're going to use in the code. So the next thing is we will go over here to Samsung Commander, and you see the loop here. Looks for each one of those codes that we just saw in the serial monitor, and takes an action based on it. The only other thing I'll mention is I did add a face, a Mr. Bill face, as an oh no, to the other one, so we have an additional face on there. So I'll upload. And we'll go over here, and there you see a nice smiley face waiting for us. That should change to a neutral face. Yep, okay, again, that's in the setup code. So up arrow gives you a smiley face. Right arrow gives you a blinking yellow neutral face. Looks orange to me, but it's supposed to be yellow. That's a frowny face. And there's Mr. Bill. Oh no, you're getting too close. So that's that one. And if we press any other, that's the default, is a blinking frowny face. So it could be anything. A little more capabilities of the matrix, plus a much simpler way to decode and use the decoded IR signals. So next we'll show one more remote. Okay, just one more thing. I had this remote in inventory. This is a Radio Shack. I think it says Radio Shack someplace on it. And there it says that I bought from some surplus supplier the last time Radio Shack was in bankruptcy. The sad thing is that my local store, as of this date, which is April 16th, 2017, has less than 2 weeks left before it closes, and all the Radio Shacks in the universe will be closed. This is the final end, and that's a sad thing. My store is only less than 2 miles from my house, and I got to use it for emergency supplies, and as well as some kind of neat ideas and stuff. But they're gone anyway. I had this remote, so I figured I'd try to use it too. So I went back to Chris Young's code. As if you can see on the serial monitor there, it says unknown. So we couldn't decode them using Chris Young's process. So I had to go and decode them using the original process from the IR remote code from the original tutorial, which is old. I know that it's old because the samples had .pde extensions, and that's like the less than version 1.0 something of the IDE, so that's a long way back. Anyway, so you see I've got used switch 1 and switch 2. I didn't want to go through a whole bunch more, but this code I believe is uploaded. No, it's not. I've got uploaded. Sorry, because I was doing the other stuff, doing the Chris Young code to show you that it was. And while I was compiling, I'll let you know that I looked at this chip here, and it's a PT 2248 chip, and evidently it uses the Toshiba protocol, which Chris's code does not support, as far as I can tell. Well, it doesn't because of the code, but I looked in the various protocols that he supports, which are numerous, and Toshiba wasn't one of them. But if we press switch 1 up, got to turn this on. So there we are, it's on. So if we press switch 1, it gives you a smiley face. And switch 2, it gives you a neutral face. And anything else, it gives you a frowny face. So just one more experiment with IR and remotes and stuff. Just thought that might be interesting. So that's where we are with I'm sorry, I've got one more. I've got one more example playing with motors, but the idea of the robot gave me some ideas for future robots and future controlling. So we can also show you controlling some motors next time. All right, so here's the other robotic piece. We have a breadboard with a feather. That's actually it's a blue fruit BLE feather. Because we can do Bluetooth also with this, but I'm not showing that's the subject from their video. And on top we have the PWM servo feather wing with 2 servos attached. Actually, there are 2 continuous rotation servos. I actually had to look at the data sheet for these FS90Rs to see what the minimum maximum rotation speeds were, so that I could adapt the code to it. But that's a different story. So let's see what happens if we first It's already, the power is turned on. So they go forward, I turn. If I go to the right, only one turns. If I go to the left, just the other motor turns. And if I say backwards, they go backwards. If I say forwards, they reverse. Right, left, backwards, and stop. So that's another way of controlling a robot. So that's I'm building all that. I'm building up to a experiment with my granddaughter where we're going to put something together. Um, by the way, the servos in that robot are continuous rotation servers. So I had actually adapted some of the code from that and some of the code from a variety of places, but this all works and we're happy. Okay, just one other thing about the robot here, the infrared sensors. I'm going to turn them on, let them go, and then I'm going to take out the remote, and the infrared from the remote is picked up by the infrared receivers, even though they're faced the other way. So he just reset himself. There he goes. So another way of controlling this thing is the battery is running very, very low, which is why he's stopping and resetting. But anyway, that's press the remote and the robot turns. It reacts to the IR. Pretty interesting stuff. So, thank you. All right, so that's our experiments, fun with IR, as I say. And I really did enjoy this. I learned a lot, and I had a lot of fun. So what we did, we started out showing how the robot that we built with infrared sensors, actually infrared transmitters and receivers, was able to do proximity sensing by bouncing IR off obstacles and then receiving, and based on the timings, um, the code would take action to move around obstacles. Then we showed two different ways of decoding IR. An older way that's not that's a little bit more complicated and not quite as idiot proof. And then a very nice way that has just been defined recently. Take a look at the Adafruit Learning System and look at IR Lib 2, which by Chris Young, which is on GitHub, but it's also referenced in the tutorial. Reference in this video, and also I'll if you look at my blog, virtualmachine.blogspot.com, I'm writing out the same thing, which will include a copy of this video and with references to all the code that we've used. Then a couple of other things showed how I used an IR remote to control servos. I showed the difference with a different remote, a Radio Shack remote that used a different protocol, how we had to go back to the older method to decode the IR. And then finally, what we did, how IR affects the sensors, the IR receivers that are on the robot. Kind of interesting. So it's all fun. Um, and we're building up to a project, as I said, that we'll be doing this summer. You will see more about that. So until next time.